Okay, so a couple case studies here. So this is Ethanol that went ahead and integrated a fully paperless design and manufacturing items here. So they leveraged NX and Team Center. So they created electronic annotated 3D models, and they were successful in their first prototype manufacturing, and it was considerably reduced. So it's one example of a fully PMI implementation here. Okay. GM as well has adopted PMI in some of their programs. So here's a quote from a GM engineer. It said NX PMI helps to reduce misinterpretation of GD&T requirements that occurs with traditional 2D drawings. So we talked about how you can use that PMI data applied to a 3D model and push that to your NC programming. So now, there's no misinterpretation on what surface this this tolerance will be applied to, right? Or which holes, or what datum features are being called out. So things like this, it's easier once you have the model. You can fully interrogate what those tolerances are being applied to. Okay, so here's a quick overview of the demonstration for today. We'll first start off with just a quick review of a published 3D PDF that exists. Take a look at how the end user will interact with this PDF. And then we'll start and create one ourselves. So, the typical example here or scenario is there's an existing drawing, and you want to leverage that and create a PMI environment, and then publish that with dimensions, your notes, datums, or run a GD&T checkmate test, and then we'll go ahead and publish that into a PDF and review that as well. And then, if time permits, we'll quickly just view the template side of things. So if you're interested in adopting PMI environment, you can take a look at how those templates are created and how to assign different items in there. Okay, so for this demonstration, I'll be working with this housing part. So this is the 2D drawing of this part. And what I want to do is I want to convert this into PMI objects. Right? So the first thing I want to do is I want to go to drafting tools. And here you'll see this convert to PMI feature. So if you click on this, you'll see a couple options here. You'll see you can convert drawing, the entire drawing, a specific sheet, view, or a specific annotation. Okay. So for this example, this is a fairly large drawing here. So I'll just grab a couple views just for the sake of this demonstration. So what I wish to do is convert this right view, this projected view, this section view here. Okay. If you have specific conversion settings, you can go ahead and add them in here. Right, this gets a little bit more advanced, but you can set up rules and customizations. Okay. We'll have the open converted PMI destination part checked. If there's an outside assembly or part you wish to convert, you can select this. And this just gives you a couple more options on what settings you wish to change, right? So you can come in here and really be very specific on what your outputs should be. Okay, so this looks good. I went ahead and want to convert these three views, and you'll see the preview captures all the dimensions and tolerances. So I'll click OK. And so what this is doing is it's writing to the 3D environment. Okay, so this is my housing part. If I go to my part Navigator, you'll see there's a PMI folder in here. And you can expand this, and this has all the PMI data from that 2D environment. Now, if you expand model views, you'll see there's the right view in here. So I can double click and make this the working view. You'll see it captures those PMI data and supplemental geometries from the 2D environment, brings it on here. I can go to my ortho view, right? So this is that projected view. And I can go into my section view here. Right, so those are the 3 drawing views that were brought in. What you'll notice is that any view that has this plus symbol here just lets you know that there's data assigned to this view. So you can always organize this however you want. When you convert, there's an option there to add a prefix to, so you can have something like PMI underscore and then the name of the view, or rename them entirely if you wish. Okay, and so what we want to do here is now, if you don't have or you don't see this PMI tab in your ribbon, you'll want to go to your application tab. And depending on what version you have, you might see PMI as its own icon, or you would have to go to toolbox and check PMI. Okay. So now that will grant you access to your PMI features. So here, this will look somewhat familiar, right? You have most of the same tools as you do in your 2D environment, but now they're applied to your 3D model. So you have dimensioning tools, annotation tools, GD&T features, tables, supplemental geometries, and so forth. So what I want to do for this example is just apply a couple dimensions, right? Just to go through that exercise and then publish this into a PDF. So what I want to dimension from here is this hole. So first thing I want to do is grab the center mark of that hole. So you'll see that there's a couple of different options here for the supplemental geometry tools. And so for this example, I want to use that center mark. Click on this edge. And now I wish to dimension that hole. So when you apply a dimension, because we're in a 3D environment, you'll have to select a plane on which that dimension lies on. So you'll notice that these dimensions are on different planes, but when you click on this section view here, or when you make it that working view, you'll have everything basically look the same as your 2D environment. And so what we want to do here is just call out this hole. So I can go ahead, change this like same tools as I have in my 2D environment. Go ahead and select that edge. We'll first select my my plane. So I can come in here. Right now, this has my plane selected there. So let me go ahead and first set that plane. So my alignment tools, right? You have an option here to select a section plane, a log plane, or a specify a plane. So for this example, I can just specify an existing plane. I can take a look at my model history, grab a plane from there. It doesn't look like there's an existing plane here. So I can come back, use my section plane. Okay. So once I have that set, I can go ahead and create my my dimension. So this is my diameter. My diameter dimension. Go back here, grab that again. Okay, looks like it's not letting me. Let me change my alignment here. You'd basically just grab that the same way you would do your 2D environment. Let me place my object alignment to my plane. Let's create a plane here first. So typically you would have your datum features in here. This was converted to from a set file. In this case, I'll go ahead and just select that plane there. Okay, so let me go back, diameter, specify my plane. Okay, so there you go. I have my diameter set. And that's this object here. Let me grab a different dimension here. I think it's because this isn't entirely, it's considered a curve, not an arc there. So let me redo this. Let's do a linear dimension instead for this example. So my placement will still be the same. Placement will be, let's see, orientation, specify plane, come in here. Rapid dimension, I want that to be from this surface or this edge. And we can talk about the use cases of using the surface rather than the edge. I can come in here and I can select, go ahead and select this point here. And now I'm creating my object in this plane here. And so one thing I want to be aware of, because we're using this part in your manufacturing side, it matters what you have as your associated objects. So if I come in here, double click this, and take a look at my associated objects, I now see that I have this surface highlighted in blue and that center mark highlighted in blue, right? So you're basically telling the CAM side of things that you want to dimension from that surface to that point, right? And you can also add additional associated objects too, right? So now they know it's going to be that center of that hole and that surface there. Right? And you have the same tools you have in your 2D environment, but now you can go ahead and change your tolerances from here, do the same thing we're all used to, change your settings and so forth. Okay. So let me hide this and clean this up. So it's important, I briefly went over associated objects, but it's important to consider those, especially when you're converting your drawings from 2D, right? Because like I said, it matters when you're on the manufacturing side of things. So for example, this perpendicular tolerance of this hole here should be dependent on items A, B, and on this hole here. So if I double click this, because it was converted, it doesn't have those associated objects. So you would have to come in here, you can add this as an associated object, or you can just drag this and just simply by getting close to this, it goes ahead and attaches that associated object, right? So now it goes ahead and captures everything that was brought in from this 67 diameter dimension. Okay. So now it's easier for that NC programmer to take a look at this and see what objects are being referenced. Okay. You also have the option to add notes in here. So you can add notes a couple ways. You can do it from your model views using the note option here, or you can have it as part of your template where you ask someone to manually write your notes in during the publish portion of this session here. So for this example, right, we'll show the ISO view here. Now I can go ahead and change my view settings so it's not rendering. And I can apply a note on here. If you have a standard note, this is where you would go ahead and enter it. Here it's just asking me which plane I want to set this note. Right now it's the view plane, so I can just enter it here. And so for note, material, 2, 3, etc. So you have the same tools. You can bring in symbols in here, import a note if there's a standard, right? Inherit if you have an existing part already completed, you can just inherit that note in those settings if needed. There's a lot of ways you can go ahead and tackle this. You can go ahead and set these notes to have an associated object as well. So maybe there's a flag note on a specific surface. You can go ahead and call that out as well. Okay, so now I have notes on my ISO view. I have my dimension on my projected, my right, and section view here. Now I want to show how the export process looks like. And so if you already have a template in place, all you would do from here is go to your publish tool, select your template. In this case, I want to go ahead and use this template here. And you have a couple options when you're exporting. You can include all the views, selected views, and any disclosed views. In this case, I'll just have all in there. This will basically define where I want to output this file. If I want to set a password on here, I can do so. Right? I'll just type in password. You have a couple options for maximum accuracies, some compression options. If you wish to override some of those colors, you can do so. Right? That's helpful when you want to print this out. Okay? And when you have a template in place, similar to the title block in your 2D environment, you have options to fill these parts out, like the part number. And if you have something more automated and standard, this would just grab your part attribute. So this gets filled out automatically here. Okay. I can just leave this as is. And you also have options to attach documents to this technical data package. If you need to attach specs, an analysis report, anything you need to get this released, you can go ahead, browse for something, and attach it. All right, so now this looks good. Now I want to export. And so that's grabbing all those dimensions and printing to Adobe's 3D multimedia content. So we'll take a look at how that appears on the other side. Okay, so this went ahead and prompted me to enter a password. And so now I have my template and my parts exported here. So this can be configured and customized in lots of different ways, right? You don't have the traditional 2D environment where you just have views all over the place. You can set it up that way if you wish, or you can have something like this where you have those views shown at the bottom here. Right? You can go through the different views, take a look at that ortho view, and the dimensions applied to those views, right? That cross section, and so forth. And so what you can do as well, because it's a 3D environment now, is you can manipulate this. You can take a look at the different parts. You have tools in Adobe where you can manipulate the model, measure, or take some screenshots as well. You can go into your views, change your views from here as well, go through your different options of your rendering options. You can change your background color, add cross sections in here, and so forth. So it makes it really easy for you to interrogate the model, right? So you have both this and the dimensions available to you. And so one thing we'll see with the dimensions is when you go ahead and interact with your part, you'll see that you'll have you're able to select on specific component dimensions needed, and you can see what it's applied to. So here, it just makes it a little bit more accurate to select the different parts. Now, the second sheet here is just another example of how you can set this up. We talked about the example where you have the table at the bottom or the ribbon at the bottom, go through different views, right? You also have the option to have it set up this way, where it's just a detailed list. So you can toggle those views, right? You can resize these. You can have multiple. So whatever makes it easier for you to view this. And of course, you'll have your standards and your tolerance blocks in there if you wish. Okay. Notice how these title blocks just filled out when I entered those properties in the publish section. So makes it very easy to go ahead and just export that. You can export the 3D viewable as well, step file, and everything's captured if they need it. The last thing here is you have your checkmate tools. So the out-of-the-box tool for your PMI are your GD&T validations for both semantic and syntactic. So if you're within the checkmate options, you can go ahead and set up a new test, search for that PMI category, and then add all these different views or tests in there, and then run this test. Okay? It's helpful because now you get some good information on here, right? So when I ran this test, I got a couple errors, so I can now interactively redline this drawing and take a look at what failed, right? So here I have a failure on this feature control frame, and if I hover over this, or if I go show info view, you can see what the error that's being called out. And so this says it failed because the reference secondary datum feature is not present in the work part. So the secondary being B, datum B, this is letting me know that there's no datum B feature or datum applied anywhere on this part. So I went ahead and call this out, right? We have A, we have C, but there's no B in there. And of course, if we need B and it's already created, we would just go into our drawing and convert it, and that would solve that issue there. So there's a lot of time it can help, right? So you can just run that test, automate it. You can even set it up where you run a checkmate test at every time you save, or if you're integrated with Team Center, anytime you check in your part.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.